Let's say we're playing a game where we roll a die, and if you roll like a 5, you get $1. If you roll a 6, you get $3, and if you roll anything else, you lose $2, something like that. Okay, is that game gonna win you money? That's kind of, or if not, how much are you gonna lose, or how much are you gonna expect to gain? So that's kind of the question. This doesn't just apply to games. It could be like a business model, or sometimes, like in basketball, if you're making 40% of your threes, that's like comparable to making how many of your 2-pointers? That'd be a similar type question. Does anybody know the answer to that? Well, if you're making 40% of your threes, because threes are like 1.5 times worth more than your twos, that would be like making 60% of your twos. So, you know, if this percentage is better, relatively speaking, then you might want to shoot more threes, or if this percentage is better, you might want to shoot more twos. Anyways, it applies to a lot of stuff, but let's do that example I said. So I said if you make a 5, so what's the probability of making a 5? If you roll a die, what's the probability of rolling a 5? 1 in 6. And I'll make a little table here. That's kind of what the book did. So the probability of rolling a 5 is 1 in 6. And how much did I say you get paid? $1. $1. Okay, if you roll a 6, what's the probability of rolling a 6?
1 in 6.
How much did I say you get paid? I think I said $3. Okay, I just kind of made this up on the fly. Okay, what's the probability of rolling something else besides a 5 or 6?
2/3.
Yeah, 4 out of 6, or if you reduce it, 2 out of 3. And I said you do a $2 loss. Okay, should we, if we keep playing this game over and over, should we expect to make money or lose money? Okay, how do we figure it out? And in general, how much would we expect to win or lose? That's kind of the question. So all you do is pretty simple. It's like 1/6 of the time you can expect to win $1. 1/6 of the time you can expect to win $3, and 2/3 of the time you could expect to lose $2. And you plug that in. 4, 6, 30. I think it's -4.6, which is like negative, it'd be like -0.66. We're talking about money here. So in general, you should expect on an average game, overall, you would expect to lose 66 cents. Okay, does that make sense? So it's not a game you want to play. This is like how gambling works. Gambling, of course, whatever the game is, they want you to lose money. So they set it up so overall, in general, you'll lose money. Occasionally you'll get some money, but in the long term, you start losing money. Anyways, so this is what they call the expected value. Now, can you lose 66 cents by just playing, like rolling the die once? No. These are the 3 options. But overall, it kind of averages out to like a 66 cents loss per game. That's what it means. Okay. So on number 1, they use decimals instead of fractions. But we just have to figure out the expected payoff, expected value. So 0.1, that means like 10% of the time you're going to get a 9. They're not giving you any context for this. Okay, 30% of the time you'll get a 7. And 0.6 60% of the time you'll get a -5. Just plug that in. You guys see how I set that up?
0.
Okay, yeah, this one comes out as 0. If it comes out as 0, that means it's balanced, and if it's a game, they would call that a fair game. Like you have equal chances of winning or losing. If you're talking about like a business model, it would mean you wouldn't expect to make any profit. So that would be a bad thing. Okay, numero 3. 40% chance of getting a 60 plus a 30% chance of getting 52. 10% chance of getting 50. That one is 24. This one is 529 plus 26.
About 55.
Were these all positive? Yeah. Those were all positive. Okay, for exercises 5 through 8, decide if each game is a fair game. If not, state which player has the advantage. Alright, number 5. A die is rolled if the number shows is odd. Player A wins $1 from player B. If both are, let's see. If it is a 6, A wins $2 from player B. Otherwise, player B wins $3 from A. Okay, so I'll say A is like represents the positive, and B will be like my negative. So if the number is odd, player A gets $1. So what's the probability that you would roll an odd on a die? Right. Odds are like 1, 3, 5. That's half the die. So half the die, player A is going to get $1. Half the time. And then player A gets, if it's a 6, A gets $2. So what's the probability of rolling a 6? Player A gets $2. And then if anything else besides that happens, player B is going to get $3. So I guess we could just write it separately instead of like subtracting player B's value. We can just write it down here.
Would it be 2/3?
Right. So player A wins if he gets odds or a 6. That's 4 of the numbers on a die. So that leaves 2 of the numbers, 2 6, or 1/3 of the die. Player B is going to get $3. So this is like player A, player B. I guess we don't really need to subtract them. Doesn't ask for the expected payout. It just asks who's going to win, basically. So we just compare these. So this would be 1 1/2 plus 1/3 is 5 6, isn't it? Okay, so is this a fair game? No, player B is going to win more often, or not more often, but win more money. This represents like $1 and 5 6 of a dollar. So player B is the winner. I guess I put it's not a fair game. Column B. Number 7, 2 dice are rolled. If the sum is 6, 7, or 8, player A wins $5 from player B. Okay, how did we figure this out once upon a time? What's the odds of rolling a 6, 7, or 8? Huh? Well, there was a table way back. How far back was it? I'm still looking. Page 601. Okay, on 601, it shows all the combos. So we need what's the probability of rolling a 6, a 7, or an 8. So remember it kind of goes in diagonals. 6 diagonal says like 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. So there's like 5 ways to roll a 6. You guys looking where I'm looking? Wake up, 601, yes. You're gonna have to do this yourselves here in a minute. Okay, to roll a 6, you could get a 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. You need to find that diagonal in the chart there. So there's 5 different ways to roll a 6. Out of how many combos are there when you roll 2 dice? How many different combinations? 36. Remember that? So 5 and 36 ways to roll a 6. How many ways are there to roll a 7? 6.
16 out of 36.
And to roll an 8, 8 would be the same. So to roll one of these 3, it's that or that or that. It's 16 out of 36 chance. Okay, I'm not going to reduce it because it doesn't really matter. If it was the final answer, you'd need to reduce it, but in this case, I'm just going to keep going. Player A gets $5. So that fraction of the time, player A is going to get $5. Otherwise, player B is going to get $4. So what fraction of the time will player B win? Right. If 16 out of 36, player A wins, that leaves 20 out of 36 for player B to win. But B is only going to get $4. So who gets more? Yeah, I kind of wish I had reduced it. That'll be 4 ninths. 4 times 5 is 45. Oh wait. 20. A little over 2. And this one, if we divide by 4, is 5 ninths. Oh. Well, it's a tie. So what does that mean? It's a fair game. Okay, number 9. Suppose you play a game in which you make a bet and then draw a card from a well-shuffled deck that includes the standard 52 cards as well as 2 jokers. So we got 54 cards actually. If you draw a joker, you keep your bet and win $5. If you draw a face card, you keep your bet and win $2. And if you draw any other card, you lose the bet. What's your expected gain or loss on this game if your bet is $1? Okay, so let's start with the jokers, I guess. Start at the beginning. So what are the odds you will draw a joker out of the deck? 2 out of 54. And what, say you get $5 for that? Yeah. You get 2 out of 54 of the time you get $5. Okay. Then you draw a face card. How many face cards were in a deck? Do you guys remember?
There's 12 of them.
Yeah, three in each suit, 3 times 4. There's 12, but it's not 12 out of 52 now. It's 12 out of 54. And what did it say you get? How much money for that? $2. Oh, I forgot about the bet thing. Darn it.
So you're already giving money $1.
Well, actually, I think this is fine because you get your dollar back, but then you get this as a profit also. That's what it said, right? Draw a face card, you keep your bet and win $2, yeah. So the profit's still $5 or $2, remember. If you draw any other card, you lose the bet. Alright, so what are the odds we're going to lose?
40 and 52, right? 40.
Yeah, so 14 out of 54 we win, so that leaves 40 out of 54. We're going to lose our dollar.
Can we just like go to the casino for this class? I swear I'm better with that. Yeah,
Let's-
if we can
let's
get some
put it to
real life
use.
experience.
I think you probably have to be 18.
Yeah, Mama, there's this.
Brady could be our coach.
Someone was really good.
Yeah. Somebody over here. Really good dinner.
It's unfair.
Was yours something good?
Well, okay, on this one they didn't ask if it's fair or not. They just said, what's your expected gain or loss? So what popped out of this?
-1/9.
Okay, in money form, what's -1/9?
11 cents.
It's like 0.1 repeating, so that's, yeah, like -11 cents. Or we'll just say 11-cent loss. When was the last time you guys wrote a cent symbol?
We're up for a while.
6th grade?
Never.
What's your favorite animal? That was so funny. They were so confused.
We were so lost. Leah would have never got it. I was
No.
like,
my
wow. I was like, why would it be an owl?
I love